So we've been talking about exponential functions all last week. Today we're going to be working on exponential word problems. Now I like exponential word problems because they are real world situations, and it's something that I find that you might find interesting as you may be able to apply it to your everyday life. So when we have exponential word problems, we'll have growth problems and we'll have decay problems. Now you're going to have to determine when it's growth and when it's decay. But we are able to use this cheat sheet that you will also have on your Edmodo to help us. Now, if you have a printer, I would recommend maybe printing this and having it next to you when you do your problems. If not, it's no big deal. You can always go back and forth on your computer to help you. Now, if you notice, we have the keywords. We have keywords for growth would be interest. So, for example, if you put money into a bank account and it grows because you're gaining interest, that's going to grow what we call exponentially. So remember the exponential graph, it looked something like this. So it started here and then it just shoots right up really fast. And remember when we had decay, the decay started up here and it went down like that. Okay. So when you see the word interest, that means we're going to be growing. Increase, inflation, grows, appreciation, and rises. So, appreciation, maybe something might appreciate in value. That means that the value of that item is growing. So that's when we would use growth. Now, decay, when you see words like depreciate. So, for example, a lot of times cars. When you have a car, you buy a brand new car, the value of that car depreciates or decays and gets lower. Decreases, reduce, withdraws, decays, and eliminate. So those are words, when you see those, you're going to use the decay formula. So now let's take a look at the exponential formulas for growth and decay. So if you look at growth, we have right here, A equals P parentheses 1 plus R to the T power. So P is going to be your initial value. So what that means is that's the number that you originally started with. So for example, if we're talking about a bank account, your P would be the amount of money that you begin with before you started earning interest. Then we have 1 plus R. R is the rate, but as a decimal. This is really important. It must be a decimal. Now I'm going to refresh your memory on how to convert percents to decimals. That we'll refresh in this lesson. And T is pretty easy to remember because T just stands for time. Now those are going to be the same in the decay formula. The only difference is that you're going to see a plus you're going to see a minus instead of a plus. Because remember, when you're decaying, we're subtracting instead of adding. So I'm just going to highlight these so you can see what I'm talking about. So R again, this is the rate as a decimal. So there you have it. So now we have the growth, we have the decay, we know what each one means. So let's turn to some of these problems here. So let's take a look at number 1. Now, when we do these, you're not always going to see these boxes, but you can always set these boxes up yourself. So the first step in doing this is you must decide, is it growth or decay? After we read the problem. Then we're going to list our initial value, rate, and time. Now they have initial value as A. In our cheat sheet, we have it as P. We can even, we can go like this. We can just cross it out and call it P. And then this last step is we're going to substitute in. So let's read the problem. On January 1st, 1999, the price of gasoline was $1.39 per gallon. If the price of gasoline increased by 3% per year, what was the cost of 1 gallon of gasoline to the nearest cent on January 1st, 3 years later? So first things first, we have to decide, is this growth or is this decay? We could read this problem again and look for our key word. So there's going to be times where you're going to have to read the problem more than one time. So let's see. On January 1st, 1999, the price of gasoline was $1.39 per gallon. No keywords there. Let's read the next sentence. If the price of gasoline increased by 3%, increase, there is my key word there. If we look at our cheat sheet, you'll see that increased means to grow. So we know it's growth. That's why I highlighted growth. So now what we need to do is we need to fill out the initial value, the rate, and the time. So let's see. On January 1st, 1999, the price of gasoline was $1.39 per gallon. So it started, or initial means start. So the price of gasoline in this equation started at $1.39. If the price of gasoline increased by 3% per year, so here's your rate, the 3%. So 3% is my rate, but remember, R is your rate as a decimal, so you must convert it to a decimal. So whenever you see that percent sign, you're going to, here's my decimal at the end of my 3, right? If you remember, if you have a whole number, it's going to be to the right of it. You move the decimal point 2 places to the left. So now here is my decimal point, and I fill in any empty loops with a 0. This should be a review. So now my percent as a decimal is 0.03. So remember, percent to decimal. You move the decimal place. Uh-oh. Sorry about that. Decimal place. 2 spots to the left. Okay. It's good to make that note. All right. So now, my time. What was the cost of 1 gallon of gasoline to the nearest cent on January 1st, 3 years later? So my time is 3 because it's 3 years. So since the equation is my growth equation, my equation that we're going to be using, if we look back at the top, is going to be this P times 1 plus R to the T. So we're going to write that down. So A equals P times 1 plus R to the T power. And we just substitute in our numbers. So P is, remember, my initial value or my starting value, which is $1.39. 1 plus R is going to be 0.03 to the T power, which is 3. All we do from here is we're just going to type this into our calculator just the way we see it. So we're going to do 1.39 parentheses 1 plus 0.03 and raise that with your caret in your calculator to the 3rd power. So when we do that, we end up with 1.51889 ... But if we're dealing with money and they want to the nearest cent, remember money goes to 2 decimal places. So we look at the 1 in the hundredths place. You look next door, it's an 8. 5 or above, give it a shove. So that means it's $1.52. So that means that gasoline 3 years later is $1.52. So why don't we try another one? So let's take a look at number 2. The annual inflation rate is 4.2% per year. If a movie ticket costs $10.25, find a formula for P, the price of the ticket, T years from today, assuming that the movie tickets keep up with inflation. So, let's look for our keywords here. So I see the word inflation. If we look at the top and we go and look for the word inflation, we find it here. So that means that we are going to be using the growth equation. So now if I go down, here we go. My equation I'm going to be using is A equals P times 1 plus R to the T power. Remember, initial value we are calling P. So if I read this line by line, I should be able to get all the information and fill it in. So the annual inflation rate is 4.2% per year. So I have 4.2% per year. So that is my rate. Now, I know it's a decimal here, but it's also a percent. Whenever we see that percent sign, we still have to move that decimal place 2 places to the left. So if I have 4.2%, in order to convert that to the rate, we have to move the decimal 2 places to the left. 1, 2. Here it is. There's my new decimal. I fill in any empty spots with a 0. So my new rate is 0.042. If a movie ticket costs $10.25, okay, so that's my initial value. The price of the ticket T years from today, assuming the movie tickets keep up with inflation. So they don't give us a time, they just give us a T. All they want here is they want a formula. Find a formula. That's all they want. They just want a formula. Okay, so we don't actually have a final answer here. So I'm going to plug in. A equals, my P is 10.25, 1 plus my R, 0.042 to the T power. We don't have T. They just want us to find a formula, and that's exactly what we did here. Okay. All right, so we're going to do one more. So if we take a look at number 3, a vehicle was bought in 1999 for $25,000. If the car value depreciates at a rate of 2.5% each year, what will the value of the car be in 2002? So I see a keyword here, depreciates. So if you look at your cheat sheet, you'll see that when we see that word depreciate, we're actually decaying. So, initial value, they bought the car at $25,000. So that's my initial value because that's initially or starting, that was the starting value of the car. Now rate. Again, we have this 2.5%, so we have to convert that to the decimal. So again, we move the decimal place 2 places to the left. So it's going to be 0.025. Now, they don't give us time. But they tell me the car was bought in 1999 and they want to know in 2002 what the cost of the car would be. So we have to figure out how many years are between 1999 and 2002. So we can count using our fingers, or we can do the year that we have to find, subtract the year that they purchased it. So if you do that, you'll see that it's 3 years. So your T would be 3. So you have to figure out how many years have passed between 1999 and 2002. And you can always do that by subtracting. All right, so we know the equation we're using, the decay equation, which you can see on your paper, is P parentheses 1 minus R to the T power. All you have to do is plug into that. So we have 25,000, 1 minus, the rate is 0.025, and T is 3. So we're just going to type that into the calculator. And we end up with 23171.48438. Now, we're talking about money. When we're talking about money, we're talking about the price of a car. We want to round to the nearest hundredths place because we're dealing with dollars and cents. So we're going to look to the one next door. 4 or less, let it rest. So we're letting this 8 stay as an 8. So we have 23171.48. So what that is telling us is that the car depreciated or went down in value, and it in 2002 is now worth $23,171.48. So that is what our growth and decay problems will look like. I definitely recommend using that cheat sheet that you will have posted on Edmodo. Once you have your values and you plug them into the equation, you have your answer. So really just reading the question and finding the values is the hardest part of this, but I know you can do it.